Start. Okay, everyone, thank you for coming. Thank you for coming on time. So this is our first lecture, and as always, I know that the quality might suffer. That's why I will share with you the link. Turning on my camera for whatever reason. Okay, Kuliara, I hope you will fix this reason. So I'm sharing the link of the presentation with you guys so that you can enter and see it on your own in case mine is not that much visible. All right. So Lecture 1, we're doing it today, and it's just a basic introduction to wastewater treatment plant. Today, we're going to have a super short introduction of wastewater treatment plant. So we are going to cover importance of wastewater treatment plant both in Uzbekistan and around the world. And we are going to look at some wastewater basics, like what wastewater consists of, and what are the main stages in wastewater treatment plant. You should be familiar with this to some extent, but I want your knowledge to be like full. And also, we're going to have window session by Humayun, which will be shifted to the start, right? Okay. So right now, we're going to have a window session by Humayun, and he's going to explain about the history of wastewater treatment here in Tashkent. So Humayun, the stage is yours.
All right, thank you. So my part was to research and present about the history of wastewater plants in Tashkent. I want to start off with a little more general kind of water distribution systems. As you may start getting an idea, most of the water infrastructure in Tashkent was built during either the imperial time or the Soviet time. Before that, before 1930s, people here got their water primarily from like arık and havuz and lakes and all that stuff. So there was no major infrastructure. But then in 1931, there was this first, not wastewater treatment plant. It's more like a small water distribution system. Basically, it gets water from lake and distributes, basically. So 1931 is an important date, I think, because that's like first time ever, doing that. And obviously, it was the Russians who invested in it as well. Because in this place, we didn't have many specialists. In fact, we didn't have any. We didn't have our own money to do that. But I guess it's all in the past. So yeah. But if we're thinking about wastewater treatment, the very first kind of infrastructure, like actual infrastructure, started appearing in as late as 1960s. So that's not that long ago, actually. Before that, all the waste that was produced was just dumped into rivers. There was a little bit of mechanical kind of treatment, and most of the biological treatment came from putting chlorine solutions in the water, and so it killed all the microorganisms, and that was dumped into lake. But then, in 1961, I think, so 1960s, around that time, we have the very first treatment plant, which is Salar treatment plant. Where is it? Okay, yeah. So that is a very big kind of the first big scale wastewater treatment plant. There are numbers, in cubic meters, how much it's, cleaned and all that. I don't think it's very important just yet. But what's important to know is that that same kind of treatment plant, we use it today. I mean, it's not the exact same. Its performance increased dramatically, but still, Generally, we can, all the water distribution history in Tashkent or in Uzbekistan as a whole, we can divide into, I think, three sections. First, before 1930s, nothing. After 1930s, we have water distribution, vodopravod, but it's not wastewater, so it's just getting water to people. But then we have another section, which is 1960s till now. We have modern systems. And actually, another important date is 1971, 1970s. Why is everything ending in one? I don't know. Maybe I'm making a mistake. So 1970s, there are a couple of smart people who came up with a revolutionary way to biologically clean water. And so that technology is going to spread all over the world, and we're going to be famous for that. That's like the first time it's happening. So I think I didn't go into details, but it has something to do with a more efficient way of using anaerobic digestion to clean water. So that's important. 1970s, that's when this new technology was invented by our own people.
Small correction. It was aerobic digestion, not anaerobic, but aerobic with oxygen. Yes, we were the
They use
first
both,
one.
right?
Oh,
They use both, right? Like,
no. We use only aerobic with oxygen.
okay.
Yes, and we were the first ones not to create it, but to use it in the large scale. Yeah, we were the first one around the world, so you are correct on that.
Okay, so there were many firms, international firms, that kind of invested in this project as well. Yes, so we were cool back then, 1970s, but the thing is, it's not cool anymore because it's all old and, kind of breaking down. So now we're coming to today. Current situation is not very good, actually. I saw statistics. Most of the wastewater plants, at least not in Tashkent, they're working very inefficiently, like 30% of their potential. That's very low. And even in Tashkent, a lot of technology is very outdated. Like the tubes they use, it's very like water is leaking. Come on. And a lot of wastewater treatment plants are simply not being taken good care of. One reason is that we don't have enough people to do that. And I think that's a major problem. We don't have enough qualified people to actually manage those plants, and we simply don't have the investment. However, we are working with international development banks. One I know is Asian Development Bank, ADB, yes. So there are projects happening with international banks today, but it seems like there's still a lot to go. I think that's it.
Hey, thank you. That was a short introduction to the history of wastewater treatment plant in Tashkent. Thank you for that, Humayun. It was great. And if we were all in person, we would clap you. But now it doesn't make sense. So great. Yes, so a little bit of more information just to make you proud of your ancestors, guys. So that aerobic digestion, it was a real scientific boom at that time. So much so that scientists and the workers of Salar, so it happened in Salar, who created it, they were given a medal of Mirza Ulugh or Biruni for their scientific innovation. That was a real great thing in those times, and even right now, this is a great thing. And a lot of international experts on wastewater treatment plant came from their countries to visit Uzbekistan in order to see how this aerobic digestion thing is working. So there was even a picture of that. Yes, so that was a great boom. Another thing was that one of the things that made us slowed our work in wastewater treatment plant was the lack of finance. We didn't have money for tubes. And another point to make you proud of your ancestors is that when we didn't have enough money to buy tubes, we made a whole plant that makes tubes, and we started making it ourselves. Yes, so you remember. So, and we started making it out of, in Russian, we call it beton. I don't really know cement, maybe in English. I don't know that word. So we started making it out of beton, and that was great because we innovated. We had a shortage of money, but we dealt with this problem. So it was great. And the third thing to make you proud of your ancestors is that the major figures in the development of wastewater treatment in Uzbekistan were mostly graduates of Central Asian University back then, but now it's Milli, so National University after Mirza Ulugh, maybe. Yes, so this NUU, Milli University, it was once a great place whose graduates were great entrepreneurs, scientists, and engineers. It doesn't have the same status now, but back then it was a super great place. A second place that was famous for its graduates was Polytech University. Oh, balloons, okay. Polytech University. So yeah, these places were great. So there's 3 things you need to remember. Okay, now let's go to my lecture. Okay. So importance of wastewater treatment plant, wastewater basics, main parts of wastewater, and Windows session, we already finished with that. Now, make sure you pay attention because it's not only me talking, you listening, but you are going to have some tasks alongside. So follow me, yes, to avoid any awkward situations, right? So, importance of wastewater treatment plant. Of course, wastewater treatment is important. Without it, all of our rivers, oceans will be dumped with human waste. However, there are also practical sides to wastewater treatment plant. For example, in Israel, so Israel, you know, is famous for its water management, water efficiency. I guess it's even like one of the top countries in the world who's using its water in the best way. So currently, of course, there are a lot of shady things going on there, but we don't pay attention to this. Right now, we're speaking only out of scientific purpose, right? So in Israel, only 20% of land is arable. So is my screen visible? Yes, it's visible. So, and they have a huge shortage of water. So that's why about 30% of their irrigated water is coming from wastewater treatment plants. It's a huge part. For example, in Uzbekistan, so whatever water we have coming from Amudarya, Sirdarya, Zarafshan, Kirchuk rivers, we are using around 95 to 96% of it for our irrigation, and everything is coming from rivers. But they are using 30% of treated wastewater. If we would supplement 30% of our irrigation water and we would supplement it with wastewater, maybe Amudarya would be able to go till Aral Sea and it would be saved. Maybe, you see? So we need to make wastewater treatment plant better. And so this is the case of Israel. So there are references, actually, if you want to check this data, or later if you would like to use it in your research papers. So this all will be at the end of my presentation. And another great example of wastewater usage is Las Vegas. So I think you know Las Vegas for its casino, for its great movies, and yeah, it's a great place to kind of chill, right? So, however, it's also great in its water efficiency. I have like a small YouTube short. It's like a minute in length. So I will send it to the group, guys. Okay. No, not here. So here. So basically, before you start watching this YouTube short, I'll give you time to watch it because it's important. 40% land, not 40% land, but 40% of water. I'm sorry for the typo. So Las Vegas, so what is the issue in Las Vegas? It's located in the desert, and the only source of water is the river Colorado that's flowing by. And since Colorado is transboundary rivers, meaning Colorado passes not only Nevada, the state where Las Vegas is located, but also California, Arizona, and so on. These states have a limited amount of water that they are allowed to use, and the state of Nevada, where Las Vegas is located, can use only 4% of Colorado River, which is very super small amount for Las Vegas, for its fountains and so on and so forth, and for its crazy population that loves luxury life, right? So what they do is that they can get only 4% of water of Colorado, but they actually get 6 or 7% of water. They use it, they treat it, and put back the rest 3 or 4%. And at the end, they take 7%, but they put back 4%. And it means at the end, they used only 3% and they still have 1% left. You see, simple math. Because their wastewater treatment plant are so efficient, they can recycle the water, get more water, put the water back, and at the end, so they have more water. You see? Now you have like 1-2 minutes. You can watch the YouTube short that I sent you.
It's like 8 minutes. I don't think it's a short.
Oh, okay. I sent the wrong one then. So now, this one. Watch this one. I'll also watch one more time. So I finished. You guys too?
Yes.
Great. Come back,
Yes.
everyone. Turn on your cameras. Let me see your faces. Thank you. So there is also a bigger video. I will also share with you a timeline where exactly you can. So this is a bigger video that explains this in more detail. Whenever you have free time and curiosity, it's also important. You can watch it from 4:05, right? After the lecture. Don't do it now. So my screen is shared. Okay. So great, right? So if we would do the same, I mean, we would get crazy, innovative, and efficient, right? So we should do it, and you and me, we should work on that. So now, yes. So now you see that we have these countries who are doing great job. I found 2 great countries, which is Israel and Las Vegas. Now you have the task. I'll give you like 5 minutes, guys, and we will check your research ability. You see the names here. So Gulyara, Humayun, Ahmad Khan. I think I covered everyone except everyone. I did for everyone. Yes. So now, guys, go and check these countries and tell us a little bit about their water efficiency, about their strategies. So you have like until 7:30. You have 7:30 time to go and search. Maybe GPT would be the best. And you can tell us a little bit about what they do in 30 seconds for each of you, right? Go, check. Okay, guys, now we can start. So short, like 30-second introduction to the super crazy efficiency of water usage in this country. So, Alpamush, would you start?
Okay, no problem. So mine was Saudi Arabia. So the thing is, as you told before about Las Vegas, we know that Saudi Arabia is also located inside the desert. So it has water scarcity. So currently, it has about like 40 to 50% of reused water. I mean, wastewater treatment. But according to data that ChatGPT gave, in 2030, so we're planning to increase it until 90%.
Whoa.
So there is a question, like in what sections are they using those like wastewater? So the first one, like majority one, is 60-70% of that water is being used for agriculture, but like not food, like that people eat, but fodder crops. I mean, like food, like type of grasses that are planted just to feed livestock, and
Okay.
palms on the streets and non-edible trees. Then 20 to 25% is used for the fountains, street cleaning, cooling, and that kind of stuff. And 5 to 10% used for the industrial side, like building buildings, that kind of stuff.
Great, thank you. Delphus, what about you?
Sure, I researched about China, and as ChatGPT says, there are three main features of wastewater treatment plants in China. First is membrane bioreactor, and Google says that membrane bioreactor is a technology it's actually a biological process through which we can separate water from sludge. So wastewater will be a mix of two, and this membrane bioreactor helps us separate the two. And the next feature is integration of AI. So in wastewater treatment, the level of clearness of water will be different, and they're using AI to measure the water quality. And the next feature is anaerobic digestion, which we are researching and which I am working on. So they are using anaerobic digestion to turn the sludge into energy. And then the next important thing is China promoting a circular economy. It's getting biogas from sludge through anaerobic digestion. It's getting phosphorus and nitrogen as a fertilizer to use in agriculture. Then it's getting reclaimed water to use agriculture, to reuse in its agriculture sector again. So yeah.
Great. I think you will research China more doing your research.
I do.
Yes. And Sevinch, how about you?
Hi, can you hear me sometime?
Sure, I can. Ahmad Khan?
So Australian people are really innovative, and they are treating 67% of all the wastewater. However, they are very hygienic or something, so they are only using 12 to 20% according to different websites, and ChatGPT also say 12 to 20% of wastewater. Again, mainly it's used for irrigation, agriculture, and sometimes in urban planning for gardens. And they found an innovative way of using it. They want to protect wetlands by treated wastewater and use that remaining water from remaining treated wastewater for environmental uses.
Amazing,
And
great.
that's all.
Anything to add?
No.
Okay, great.
So Singapore is like a city just like Tashkent, and it doesn't really have any natural freshwater sources like rivers or aquifers, and it's only limited to collect rain, which they do through like huge rain taps. I forgot the name, but wait, hold on. They have 4 national taps, according to ChatGPT. They collect rainwater and then reuse it. So they actually have 2 stages of water treatment. The first one is like conventional, which is basic wastewater treatment that we're learning now. So like the primary treatment, the secondary treatment, and everything. But after that, they also do an advanced treatment, and they call it new water process. And that's water that is gonna be used for like drinking purposes, and where it is very high quality water basically. So the first thing that they do, they remove like suspended solids, bacteria, and everything. And one interesting fact, they use reverse osmosis. So if you know, osmosis is like a process where water moves from like a less concentrated salty area to a more concentrated salty area, but they use it reversely. So they apply pressure so that water moves to a less salty environment, like stays there. And all the salts and then metals and whatever, they remain at the opposite side. So they like separate the water from the salts and everything using reverse osmosis and using pressure. They also apply ultraviolet disinfection. They remove any remaining bacteria. For example, I think they remove the bacteria that was used during like aerobic digestion or anaerobic digestion processes to make it even safer. Yeah, and then they add minerals and like to make the pH neutral and then better the quality. They use like 75% of their treated water for like industrial purposes, for like building electronics and then also cooling towers, and also for pharmaceutical industries.
Whoa, amazing.
Also for drinking purposes, one interesting thing, they blend rainwater with treated water and then they treat it again, so it's like very high quality and then that people can actually drink it.
Yes, yes, it must be very expensive too also. Great.
Yeah.
Great, thank you. So, Humayun?
Okay. So Spain is one of the top countries in the EU that reuses most of its water. Actually, the EU average, for example, is 3%, and Spain reuses 13%, max 10-13%. There are nearly 2,000 wastewater treatment plants in Spain, and some of the some of the regions reused almost 99% of the water, primarily for agriculture. Also, Spain is using a lot of innovations and trends. What I found interesting is the circular economy in wastewater. Basically, sludge used to generate electricity, but using biomass conversion, and then that electricity kind of, so it's good. Making energy from nothing, basically. Most of wastewater treatment plants include like conventional treatment, primary, secondary, and in some areas they use advanced disinfection as well. Especially in those areas where water is scarce, they have to reuse every drop they can find.
Amazing.
Yeah, that's basically it.
Amazing. Thank you. Thank you for statistical approach. Yes.
One question.
Okay, yeah, sure.
How many wastewater treatment plants we have in Uzbekistan in total?
Oh, I don't have that number. Although I guess we can get it. Even approximately, I'm not sure I know it. Yes, I know in Tashkent we have like 4 or 5. Yes, yes. Yeah, maybe the book, the resource I shared, concepts, it might have the old data about it, like 2019's data. But if you are interested, we can also get it from Usultaminat.
Yes, I'm interested because Spain was it Spain?
Yes.
2,000, more than 2,000, and I'm wondering how many.
Actually, there's a beautiful map showing where all the wastewater treatment plants are, and most of them are centered around Madrid, literally just in the center. I guess that makes sense because it's.
Can you share?
Yeah, I can share. I can share this. Yeah, in the Telegram channel.
Great. Then while we're waiting, Sivinch, you can also speak.
Okay. Okay, just a minute. Okay, as we know, the United Arab Emirates is a desert country with very little natural fresh water. Most of the water people use here, like from desalination. Desalination is like they're removing the salts from seawater to drink or use for another purposes. But there is also another solution, like reusing wastewater, because desalination is much more expensive and uses a lot of energy. They instead of throwing wastewater away after it's treated, okay, in Dubai, around 90% of the treated wastewater is reused today. Okay, the goal is to reach 100% reuse by 2030 year. In Abu Dhabi, around 61% of treated water is reused across the whole United Arab Emirates. The average reuse is around 55 to 60%. Okay, some countries like Oman and Qatar have already reached 100%. And also the Arab Emirates is moving quickly to reach that level too. Okay, the main places where wastewater is reused is landscape irrigation. This is the main biggest use. Treated water is used to water parks, gardens, trees, and roads, especially in big cities like Dubai and Abu Dhabi. Also, district cooling. They instead of using clean water to cool buildings, treated water is used in cooling systems for large areas like malls and business centers. This saves both water and energy. Also, some wastewater is used in factories for making concrete, cleaning machines, or cooling in power plants. Okay. Also, firefighting and street cleaning. Treated water is also used for cleaning roads, washing city vehicles, and even fighting fires instead of using fresh water.
Great. I think we can go with Big Sotake. Although I'm afraid he's not here, so maybe South Korea will wait a bit. We will go on with the rest of the lecture because we have like 16 minutes left. Okay, so guys, just before starting the lecture again, so you see the wastewater is waste only when we waste it, right? So many countries are using it again, reusing it, so we should start doing the same in Uzbekistan. Great. So the wastewater basics. Only now we're starting the lecture. So the main sources of wastewater in Uzbekistan are coming from three branches: industrial, urban, and rainwater. So basically, urban is our toilets, our bathtubs, the kitchen one. The industrial is all from different industries like textile, the ones that deal with like обработка кожи, да, чтобы делать обувь, and also different cafeterias, restaurants, fast food places with their very oily wastewater. They are also flowing to us. So basically, you need to know that in fact, based on the water distribution, there are two types of wastewater. So there is combined one, and there is separate or sanitary called. So, so I would like you to pay attention. In Uzbekistan, I think, especially in Tashkent, we have combined one. Combined means when rain flows, the rainwater, which is pretty much pure, in fact, it also goes to wastewater treatment plant. It's being treated as if it's not pure, and then it's recharged back to rivers. It's done why? Because when the city was first built, the city administration didn't have enough money to make separate drainage tubes for the rainwater, like in sanitary sewer overflow. So you see that in fact, for rainwater, we should have a separate tubes that leave it exactly to lakes and rivers that are running through the city, not to the wastewater treatment plant. In fact, the team that is working on anaerobic digestion, you will see that this setup, in fact, ruins a lot of things for you guys. De La Cruz, Alpamish, and Guliora, because if we have combined sewer, then the coming wastewater will be very diffused, and there will be not a lot of things that you can get electricity from. Basically, this is the first problem. Another problem is that when we have excessive wet weather, like when we have a lot of rain, what happens is that the wastewater mixed with rainwater, there is so much of it that the wastewater treatment plant cannot handle. And what happens is that excess that is not treated, that is full of pathogen, human waste flows to the rivers. Basically, this was the problem of Paris when it was having Olympics. The river of Siena, it was very much polluted with human waste, and it had a higher amount of E. coli, basically the bacteria that makes you sick. So it had higher amount of E. coli. Why? Because during rainy seasons, their combined system didn't handle that much water, and that's why it would pour everything into Siena, which was bad, right? So maybe the same is happening with Tashkent. I don't have a data on it. I don't have information, but this can happen if we have excessive rains, which is not very usual for our region. We don't have that much rain as Paris does, but we still have this risk, right? So the new Tashkent, I don't really know regarding other treatment plants around the Republic, but new Tashkent is hopefully will use the separate sewage distribution network, but still I don't have information on that. Yes, so basically wastewater constituents, there are solids in the wastewater. They can be inert, like dust, like sand, like stones. They can be volatile, like every other organic, like human waste. Yes, and though they can be dissolved or suspended. Suspended means they are still present, but they are so tiny that they flow in the water, and dissolved, like salts that can dissolve in the water. There are also biodegradable compounds, like different organics, like human waste, and different nutrients that contain nitrogen, or in Russian it's sera. In English, I forgot how to name it. Yes, and also there are non-biodegradable or slowly biodegradable. Those are inorganic compounds, like solids, that are stones and sand. These are different chlorinated organics, like for those who don't have good organic background, if organic compounds have chlorine attached to them, they became very inert, and it's very hard to digest them, to get rid of them. They are so inert that actually they are used for anesthesia. Whenever you go to operation, you get anesthesia and you have some chlorinated stuff there. And also some pharmaceuticals and hormones that might be coming from hospitals are also very, very hard to biodegrade. And there are some toxic stuffs like metalloids, heavy metals that come from industries, pesticides that may come from agricultural runoff, some carcinogenic stuff, like, for example, if you have schiffer on your roof and the rainwater flows through it, and then the rainwater goes to wastewater treatment plant. I have heard, not read, I don't have literature on that, but in fact that rainwater might catch some carcinogenic compounds from the rooftop. So yes, we can have something like this, pathogenic like E. coli and something like that, and radioactive. Hopefully we don't have any radioactive stuff yet. Yes, we don't have any industries that deal with those yet. Okay, so everyone that is working on research on wastewater treatment plant should know basics of lab analysis. We have several things. If we have enough time, we don't have. I would explain you what does it mean. So we have like BOD, COD, suspended solids. Yes, we have all of these things, and you should go through those in the future. Especially those who are working on efficiency. Yes, you should go through this. Maybe you will already go during your research, so I'll not stop here a lot, you can ask ChatGPT and he will explain what exactly these things measure. And yes, right now, so basically this lab analysis show how pure the water gets afterwards, right? So you have at the beginning BOD of 400 and at the end you're getting BOD of 50 to 20 to 10, right? It shows the efficiency of your wastewater treatment plant. And now I have the data. I have data for three countries, Netherlands, Israel, and Uzbekistan. And right now, your task, guys, copy link down, is to calculate the efficiency of these wastewater treatment plants and see whether we're behind or whether we're pretty doing a good job. So we have three countries, and I think we can divide. So we have 1, 2, 3, 4, 5, 6. Okay, 2 people are working on each. Alpamış Sevinç, you're going to work on Netherlands. Humayun Dilafruz, Uzbekistan. Gulyora Ahmad Khan, Israel. So you can divide on 3 by 3 and just you can calculate the efficiency, right? How much it was before, the after, and what is the percentage removal, right? So I think you know the formula. You should know the formula. And it's already in Excel. If you want, you can calculate by hand on calculator. If you want, you can write formula here, whichever way is comfortable for you.
Efficiency for each of them, right? BOD.
Yes.
Okay.
So if someone needs help, this would be like rough formula. So just a little help. That will be something like this, and this will be something like this. Yes. Okay. Great, guys. And so now you can see with your own eyes and with your own hand and calculator in mind that we are lagging behind, at least Netherlands and Israel. We are lagging behind these 2 mega giant countries that are really good at water, but we should match them, right? So the only great part of us that we're managing is killing pathogens. Yes, we're really, really cool on that. Okay, for some reason this thing. Okay, we're like almost 100%. We're like 99.99938, something like that. We should be. So, but the rest we're behind, and we should make it better. And this will be our task for this summer, right? To research the ways how to make it better, at least a part of us. So by this, the lecture comes to end. We say bye-bye to everyone. There is also the main parts of wastewater treatment plant. There is nothing to explain. There is something to just look at, yes, because every part will be explained in detail later. I think it's still important for me to explain you this BOD, COD on my own to make it clear that you all understand. So maybe we will leave this part for the next lecture. So if you have any questions, I'm happy to answer. Else, we can stop here.
Thank you for the lecture. It was amazing.
Yes.
Any homework
Thank you.
until tomorrow's lecture?
Maybe that would be good if you would go through the chapter 2 of the textbook that we're learning right now. Yes. So otherwise, no homework particularly. Yes, just be present. Yeah. Thank you, guys. Have a great day. I hope you liked it, and bye. Till 7 p.m. tomorrow.
Have a nice evening.
Thank you.
Bye.